New topic. Yes, I'm still streaming. Good. So let me ask you a question. How many of you were taught by somebody other than me, first row people don't get to answer this question, how to interpret interactions among continuous predictors? You were taught that? What were you taught to do? You don't remember?
I think it's like you think of 1 unit increase in this versus, yeah, you're supposed to find like points that make, is that what it is?
That's one way.
Yeah.
So to figure out like what the slope would be at plus or minus 1 standard deviation of the
Yes.
interacting variable, like simple slopes. There is a term for it like called probing the interaction, which is a term that I hate. Makes me think of South Park and anal probes. Well, that was the very first like season of South Park where Cartman thought he was being trapped by an alien. And he kept talking about anal probes. That's my best Cartman. But yeah, so the word probe just makes me a little squishy. But yeah, that idea of trying to like find points or whatever. How would you get a slope for an interacting variable that's not at the reference point? Did someone tell you how to do that? I'll ask you again since you volunteered.
I don't remember.
Don't remember that? That's fine. That's why we're reviewing, by the way, if you don't remember. Does anyone else get taught this? Yes?
Probably by the same people.
Okay.
That's what I remember, but you do have to put, if you put an interaction in, you have to have it be effective.
Mm-hmm.
That's the one thing.
Yep. Correct.
And I don't know what single size comparing to the, like, except if it's just like male, female.
Mm-hmm.
Sometimes that's easy.
Mm-hmm.
Because there is only one group, if it's multiple.
If it's multiple groups or continuous variables, right? That's when there's an infinite number of
Yeah.
values that you could want the slope for. How about regions of significance? Have you learned about that yet? Nope? It's cool, right? Like, yes, she's like, I think she talked about that, right? That's why you're here again. No, this is the cool stuff. This is going to be new, even though this has, in theory, nothing to do with multi-level per se. Interaction terms are going to show up real quick in multi-level models, particularly across levels, as you're trying to explain why a level 1 relationship might differ across units. That implies an interaction term to be able to do that. So I have had a lot of mixed success in trying to teach multi-level models and how to work with interaction terms simultaneously. It's a lot easier if I can do it in a general linear model first, and then we tack on the multi-level aspect later. So that's what I wanted to do this part. But it sounds like this might be useful, right? New stuff. Some of you are nodding. Can you pretend at least? Because I believe it, right? So I wouldn't be wasting your time. I have a theory in graduate school. Anything that you could teach yourself in 10 minutes is a waste of my time and yours to be here. So I'm only going to focus on the stuff that I think is more than 10 minutesable. And I've seen a lot of people screw this up over the years, so I don't want you to be one of them. So let's do lecture 2B then. So yes, we are talking about the concept of moderation. That's the fancy word that goes with it. If you're writing an IES grant, you have to talk about your moderators, for instance, right? That's the key word. That just means interaction term. So it's the idea that the effect of one predictor depends on the value of another predictor. Which is a substantive distinction. So if I have this model up here, what I'm saying is that the effect of x depends on what z is, and the effect of z depends on what x is. Both of those are correct. I can think about z as my moderator and focus on what the effect would be at different levels of z for x as the thing that I care about, or I could do backwards. So either one is the moderator. It's not a statistical distinction. Curiously, I have found that the way that this topic gets approached depends on the type of variable. So like in ANOVA, let's say that you have like a 3x2x4 design, like an experiment, right? If you plug that into an ANOVA package, they give you all possible interactions to work with, and you never trim the model to remove them. Like that's just not done. You might focus on certain effects that are significant, but the model is what it is. In contrast, if you do regression, there are no interactions included by default. You have to decide that you'd want to test them and create the variables with which to do so. In ANCOVA, you're told that the continuous variables aren't supposed to interact. There's no reason why they can't, you just can't call it ANCOVA anymore. So what I want you to be able to do is to specify and interpret interactions among any kind of variable. Anything that is enough to test your hypothesis, that's what we're going for. So yes, what you remember, absolutely correct. The main effects stay in the model. They have to not only stay in the model, but get reinterpreted. They don't mean the same thing anymore. So when we have a two-way interaction, for instance, if we have a model that says something like a main effect of W, a main effect of X, the main effect of Z, and an X by Z interaction, we have to change the language with which we use the term main effect. So for W, because W doesn't interact with anything, we still talk about the main effect of W, the end. For every unit difference in W has a whatever slope change in Y, right? That's marginal, unconditional. X and Z, though, we can no longer say main effect. That is incorrect. It's not specific enough. It becomes what you would call either a simple effect or a conditional effect. Either of those terms would work. Simple is more of an experimental design kind of language, whereas conditional works for most things. But the effect of X is now specifically whenever Z is 0. Likewise, the effect of Z is specifically when X is 0. And so this is why centering is super important. Not only do we want to have an interpretable intercept, but we want to make sure that these slopes that come out of the model by default, that they actually refer to values that are plausible and that we might care about. But what I also want to teach you is how to get what the effect of X would be for any level of Z, not just the one that's 0 that's going to be handed to you. So it's the same principle as when you have pairwise comparisons. The model's going to give you some of them by default, but I want you to know how to get all of them without having to rerun the model. Rerun the model, by the way, is the way I was taught to do this. So let's practice. Let's say that we have a hypothetical study here. Y is student achievement on a GPA 0 to 100 scale. X is parent attitudes about education, so a Likert type variable measured from 1 to 5. Z is parents' education level. So here are my coefficients. Let's say that I run my model. I put in attitude and education off the shelf just as they're measured, and I find that I have an intercept of 30, a slope for attitudes of 1, slope for education of 2, and an interaction term between the two of 0.5. So let's play along. What's beta 0 here? 30 is you know what an intercept is? You passed this quiz last week. What's an intercept? I'll give it expected GPA when attitude is 0 and ed equals 0. Okay, so let's think about that. A GPA of 30 is not good, right? That's well into F territory. But that's what we would expect for somebody who has a 0 on a 1 to 5 scale and whose father never went to first grade. Do you think there's anybody in my study like that? I'll give you father with no education. That can happen. But literally a 0 on a 1 to 5 scale cannot happen. So 30, while being correct from a mathematical standpoint, is not a helpful estimate. It doesn't refer to anything. It's not a good "you are here" sign. Let's try beta 1. Beta 1, so y changes by 1, that's my slope here, for every unit attitude. Am I done or do I got to keep typing? When, or for, take your pick. I'll go for What's the conditionality here? Education equals 0. So I have a slope for a variable that is conditional on something that is probably not going to happen in my data set. Yes?
So when they're interpreting like this, but maybe I'm thinking the wrong thing. Is this the same thing as saying when holding a constant, y changes by 1 after every increase?
Great question. It's not the same.
Okay.
So the difference is, are you holding it constant or constant at 0?
Or if you said controlling 4, but that's the same thing, right?
Controlling 4 is held constant. Those are the same to me. That just implies that you have, the model has addressed the unique contribution of the predictor, disregarding any collinearity with the other predictors. That's what holding constant or controlling 4 means. This is another extra level, holding constant at 0 specifically. Because what this model says is that the effect of attitude is going to change as a function of what your education level is. So we have to say at 0 because that's the definition of what this means. Great question. But what do you think about this beta 1 estimate? Not terribly helpful, right? So we're 0 for 2 in estimates that we might actually care about. Let's do this one. Y changes by 2 for every unit ed for attitude equals 0. We're 0 for 3 with coefficients we might actually care about. So now what do we do with the interaction term? Interaction terms do not change y. Interaction terms change the main effects, which then change y. There are only 4 kinds of interaction terms in the world. They can take their simple main effect, either one of these, and they can make it more positive, less positive, more negative, or less negative. That's it. That's the only possibility. You have to figure out which of the 4 you're in, and then you can talk about it. So in this case, I've got positive main effects coupled with positive interaction term. That has to be a more positive. So I focus on the slope. If attitude is the moderator, then what I'm focusing on is the slope of ed. So I'd say beta 2 becomes more positive by the interaction term, 0.5 for every unit ed. Actually, otherwise, for every unit at. I was going the wrong way. That's the hard part, is to forget about y. It's what happens to the slope. Two-way interaction terms modify their main effects. Those main effects, in turn, then modify y. If I wanted to go the other way and think about education as the moderator, then I start with the slope for attitudes. Beta 1 becomes more pos by 0.5 per unit ed. So let's practice for a second here. Going out of the handout, because this is really easy once you get the hang of it. Getting a hang of it can sometimes take a bit. So what if I had a main effect of x, let's go, and I have a main effect of z, and I have an interaction. Let's go with different numbers here. Let's try that one. Okay. So if I want to talk about Main effect of X. What does the interaction do to the main effect of X as Z increases? Which pattern is this? Or positive. If I want to focus on Z instead, what? Same pattern, right? Let's do the next one. What if I had main effect of X? What happens to it as a function of Z according to this interaction term? Less positive. Less positive. It weakens it. What about if I had Z? What happens to the main effect of Z as X increases according to the interaction term? More negative. That's a more negative. It's stronger. How about this main effect of X? What happens to it as a function of Z according to the interaction? Less negative, weaker. So if it's more positive or more negative, that implies an amplification of the effect. It's enhanced. It is going for as many GRE words as I can think of that mean more. Enhanced, bigger, give me another one.
I was going to say increased, but that's not.
Stronger, I'll take increased. Magnified. In contrast, if it's less positive or less negative, it's diminished, right? Weakened. So you can use more interesting words than more positive, less positive, more negative, or less negative, but that's the pattern that you have to hang on to. So regardless of whether or not we've centered, which we haven't, and so 3 out of these 4 coefficients in my example don't mean anything, the model still gives me the predicted GPA for any combination of X's and Z's. So if I plugged in values that were more reasonable, for instance, an attitude score of 3 on the 1 to 5 scale, or an education level of 12 years, I end up with a predicted GPA of 75. So there's nothing wrong with choosing not to center your variables. The consequence is that the coefficients that are particular to 0 may not mean anything. But the model itself will still account for the same amount of variance. It will still generate the same predicted values. But I don't like having coefficients that don't mean anything. So I want to teach you how to get what the model says the simple slopes would be, those conditional main effects for any combination, whether you've asked for it or not. So for instance, if I want the simple main effect of attitudes, here's my equation up here. I have to pull out of this equation every term that has something to do with attitudes. So I don't need the intercept because that doesn't have anything to do with attitudes. I do need beta 1 times attitudes. I don't need beta 2 because there's no attitudes in there. I do need beta 3. So that gives me this. If I start with that unit of analysis and I factor out attitudes, bring it out to the front, like this, what I end up with is this compound term in parentheses is my new slope for attitudes. And you can see why the definition of beta 1 is specific to when education is 0, because that's the only point at which this compound part of the term drops. So the simple slope for attitudes for any level of education always starts with what it is for when education is 0, and then it's however much the slope changes as a function of education. So if we do this with a new reference point, let's see what would happen if we centered our variables. So we know if we swapped out our variables to be attitudes centered at 3 and education centered at 12, that way our main effects and our intercept mean something. We already figured out what the intercept would have been. It's 75. That came from the model. But we can figure out also what the new beta 1 and beta 2 would be under this new centering strategy. we go to the equation. How do I figure out what the model says the effect of attitudes would be? Well, that's what we just did. I need a beta 1 at a minimum. I also need a beta 3. So it would be whatever beta 1 used to be, which is 1, times the interaction coefficient plus the new value of attitudes. So what is it going to become? Half times 12, that's 6, right? I don't usually do math in front of you. I'm going out on a limb here. 6 plus 1, 7. That's my new beta 1. That's my new beta 1. Likewise, I go the other way. If I want to know what my new beta 2 would be, I pull out from the equation all the terms that have to do with education. Now it's beta 2 plus beta 3 times attitudes. The previous beta 2 was 2. The interaction coefficient is 0.5. And now I'm swapping out a value of 3 for attitudes. So that, I think, is 1.5 plus 2. Sound good? 3.5. Now the interaction term, is that going to change if I recenter my predictors in this way or not? What do you think? Let's go through the logic. To figure out what it would be in the new model, I start with every term that has the slope I'm looking for in it. The slope I want right now is this combined slope, the interaction term. That's the thing that I'm trying to get at. So I start with the two-way interaction. Is there anything else in the model that has both attitudes and education in it? Nope. That means I'm done. The two-way interaction is unconditional. What would I need to have to make it conditional on something else? A three-way interaction. Exactly. Three-way interactions take two-way interactions and they make them, say it with me, more positive, less positive, more negative, or less negative. Those two-way interactions in turn take their main effects and make them more positive, more negative, less negative. And those main effects then make y go up or down. You've heard of trickle-down economics? Well, this is like trickle-down statistics. So we did all of this just from the coefficients. You can do this kind of math in your head or in Excel, but more than just knowing what the simple slope is, we also want to know whether or not it's different than 0 most of the time. Doing that manually is possible, but unnecessarily annoying. So let me show you how to ask the program to do this kind of work for you. So in order of easiness, how do I get a standard error for any slope created as a compound of other things here? Well, easiest way, ask the software to give it to you. So estimate statements in SAS, test is what it's called in SPSS, LinCom is what it's called in Stata, and in M+, it's the new command under model constraint. Every software package has the capability of doing this for you. Otherwise, if you don't know how to do those things, you do what I was taught in graduate school, or undergrad actually, recenter your predictors. If you change what 0 is and rerun the model, the main effects are now different. The only problem is that how many times do you want to rerun the same model and take one number out of it each time? That's annoying and unnecessary. And number 3 is hand calculations, but I am never going to make you do anything like that. Here's how the program's going to do it though. It works out that here is the formula for your new standard error. It starts with the sampling variance of beta 1, which is its standard error squared. We throw that in. We also need the standard error squared for the other main effect and the covariance between them. That's where the math comes from. You can get those things, if you wanted them, out of something called the asymptotic covariance matrix. or you can just ask the program to use these numbers to do the math for you. So here's what it will look like. I have a SAS example, and then I have a Stata example. Which one would you like to do? SAS? Stata? SAS. Okay, SAS! We'll do both, but we'll start with SAS. It's the same. They're trivially different once you crack the code as to how you map from one to the other. So this is what our model would look like that we have right now. Attitudes, education, and attitude by education. Note that you are allowed to create interaction terms in SAS on the fly with the star. You do not have to make the new variables, which is hooray. So here are the three things that we calculated based on the coefficients that I'm now going to ask it to do so that I can get their standard error. So if I want to know, back to my original uncensored equation here, what would the predicted GPA be for a different reference point from the model? Rather than attitude and education equals 0, what would it be if they were this? Well, each of these words refers to its corresponding beta. So when I say intercept 1, what I'm actually saying is, well, I got to start with 1, beta 0. There's no variable multiplying it, so it's as if it's being multiplied by a column of 1s. Then I need 3 beta 1s. So I'm filling in 3, and this knows what beta 1 is going to be estimated to be, and it plugs in that number. I need 12 beta 2s, and then for the interaction term, I just multiply 3 by 12 and I get my 36. So this is the kind of thing that you probably learned how to do back in regression, right? How to calculate model implied values. Why would you do it here rather than in Excel? Standard errors. If you want to show like error bars in your plots, that kind of thing, you need standard errors to do that. They're much harder to calculate yourself in multi-level data, so it's good just to ask for them. Now the second two, these are what's known as simple slopes. If I want to know what the effective attitude is if education is 12, this is the analog to the algebra we did earlier. So I am asking for the effective attitudes. That means I'm asking for the term in parentheses right here that's going to multiply attitudes. So I need at a minimum 1 beta 1. So that's why it's at 1. I'm saying I need 1 beta 1. I don't need any beta 2s because beta 2 is not in here. The main effect of education does not help me predict the slope of attitudes. What is in here, though, is how education changes the slope of attitudes through the interaction term. So I'm listing the interaction term, and the number that goes after it is for the modifier, the other variable besides the one that you're asking for. So I'm asking for the slope of attitudes. I plug in the value of education that I want the attitude slope for. The last line then goes the other way. If I want the slope of education, now I'm asking for the term in parentheses. I need 0 main effects of attitudes. I need the main effect of education to start off with, and then I need to tell it what level of attitudes I want the education slope for, and I want it for 3 in this case.
Okay, only the term at 0.
Yes. Yeah, anything that is at 0 you don't have to write. I'm putting it here for pedagogical purposes. If you don't write it, it's 0 anyway. What it looks like in Stata is remarkably similar. Rather than saying intercept 1, you have their version underscore const, which is intercept. Rather than just putting the coefficient for however many you want, you literally put the multiplication in. And rather than having just spaces between the two, you have to put the plus signs. But it's the same ideas. So what goes in the line, if what you're predicting is the outcome, is every single term in the model, including the constant. If what you're predicting is a slope, the only things that should show up on your line are terms in the model that have to do with that slope. So attitudes and attitudes by education, if that's what you want for attitudes. If you want it for education, then attitude main effect is gone instead. And in Stata, you can define an interaction term on the fly with this thing right here. Who here is over 30? Raise your hands. Yeah, this thing to me is a pound sign. To the rest of you, youngins, what is this thing? Hashtag. Pound sign, right? This is a pound sign. Yeah. If you put 2 pound signs in a row, that actually gives you all the main effects that are implied and the interaction term. So you don't have to type these out if you do pound sign, pound sign. The analog in SAS, by the way, is to replace the star with the vertical bar. It does the same thing. It gives you all underlying main effects and interactions of that term. It's the vertical bar is the one if you hit shift and it's above the enter key. All right. Do you want to play? Yeah, thank you for pretending you want to play. I appreciate that. Why not, right? So let's say that we went in and we centered our predictors so that all of our coefficients made sense. How do we ask for new simple slopes anyway? Well, for this one, what I'm asking for is predicted outcomes, all right? So I gave you a hint. If you're doing a predicted outcome, you got to have the intercept in. Otherwise, the values that go here are the values for the variable that you're trying to make the prediction for. So if I want attitude equals 5, and the version of attitude that's in the model is the centered version, what do I got to put here? Other way. 2. 3 is my new 0. So if I want what it is for 5, that's 2 more than my new 0. I have seen this screwed up lots and lots and lots of times. You have to keep within the context of the model. So yes, this is 2 more than my new 0. Likewise, what do I put here for education? And my new 0 is 12. No. My new 0 is 12, and I want it for education equals 16 instead. 4. Now what goes here? 8. Yes, because 2 times 4 is 8. That's why. How about this one? If I want attitudes of 1, -2, very good. And how about education equals 12? 0. And what goes here? Yeah, what's -2 times 0? Yeah. So this one is a special case. This one would only have to adjust based on one of the main effects. Analogously, what goes here if I want attitudes equals 3? 0. What goes here if I want education 20? This is 8. And what goes here? 0. Yeah, not so bad, right?
Because I thought if you look at the original model, well, the one above, it has a -12, and then it's positive. Am I looking at the wrong thing?
Why is this one 0 right here? Is that the question?
Like, go up and then to your left. No, the one in the middle. Down.
This one?
Down 1. That one.
Okay.
Why is it 0?
Because 12 is my 0 point,
But then
and I want it for 12.
Does it matter that one is negative and one is positive?
I'm not sure I'm following what you're asking.
I think that's when she puts like -3 and -12, it's not actually -3 and -12, it's just saying.
So it can
That's
only
what
be
you're
positive.
Are you thinking order of operations? Is that the problem? Because the reason I didn't put the parentheses in is because I ran out of room.
I was supposed to look at the model above and then figure out how you were going to get that number that's in the model to match.
Oh, okay, yeah, no. I'm just literally saying if this is my model
Yeah.
and these are the predicted values you want, how do you get these predicted values given that this is the model? So we're not trying to rearrange the model at this point.
Okay.
Does that make sense? We're just getting predictions out of what we have, not trying to anticipate what something else would be, like we were doing before. So that being said, we kind of are trying to rearrange it because if you think about each of these GPAs as predicted outcomes, a synonym for that to me is a conditional intercept. Like this beta 0 is a prediction, right? It's specific to somebody with attitudes 3 and education 12. So what these lines are asking for is alternative versions of beta 0 if we had centered these variables differently. Practically speaking, you don't think about it that way, but these are predicted outcomes. It's the same thing as asking for intercepts under a new strategy. Okay, does that help?
Yeah.
Okay, other questions? Okay. So these ones are relatively straightforward because you just have to put in the value that corresponds to the level of the predictor that you're interested in. It's trickier to figure out what the value is going to be if what you're trying to ask for is a slope. So let's do some of those. If the thing that I'm asking for is a slope itself, not a predicted intercept, not an outcome, I tried to help you out here. No intercepts. You don't need to know what the intercept is to predict a slope. What you do need in each line is every term in the model that includes the slope of interest. So right away, if I know that I want the attitude slope, what goes here? 1. Because the attitude slope at a minimum starts off with a beta 1. I need 1 beta 1 to get me started. Likewise, the next one down is an attitude slope. I need a 1 here for that too. Education. That by itself is referring to beta 2. Do I need a beta 2 to figure out what the attitude slope is? Nope. Attitude ain't in here. I don't need it. It's 0. So I don't have to write it at all. I'm just plugging in the zeros implicit. Now what goes here is the conditionality. I've started off with 1 beta 1. Now I'm talking to how many beta 3s I need. So in order to get the predicted slope for attitudes, if education is 10, what goes here? -2. This is where we fill in the value for education. Because it's -2 times beta 3. That's what we need. Likewise, what goes here if I want education equals 18? 6. Now the other way, if I think about the education slope as the thing I care about and attitudes as a moderator, do I need any beta 1s? Nope. Do I need any beta 2s? How many? Just 1 to get me started. Because at a minimum, that's what the education slope is. It's beta 2 plus some other stuff if education moves off the centering point. Now what goes And the interaction term, if I want the education slope for attitudes equals 2. -1. And here, if it's attitudes 5, 2. So this is the tricky part. Even though it's the same interaction term, it's being used differently. In the first 2 lines, we've already given attitudes a value of 1. So functionally, these variables are removed and replaced by 1s. All that's left is what we want education to be. According to the interaction term, how does education change the attitude slope? The opposite happens for the interaction terms in the second 2 set of lines. In this case, we've given education the 1. So the second part is 1, and we're filling in what we want attitudes to be instead. There are macro programs that folks have written, like Chris Preacher and Andrew Hayes. This is called decomposing interaction terms or requesting simple slopes. This is the stuff that's in their program that's under the hood. You don't need any special programs if you know how to write these statements, because you can get anything you want, regardless of where your centering point is. Yes?
So is this code, will this start with estimate?
Mm-hmm.
So earlier, the numbers represent what you plug in for the variables.
Mm-hmm.
And now they're only the like multiplier of the
Yes.
so
Yes.
they're different.
They are. They're because it's a different unit of analysis. So let me go back. It's this concept, right? So the first ones you were plugging in the values because what you're trying to do is complete this main equation. What we just did is complete that part.
So SAS knows if you don't put in like intercept equals 1, then it knows you're not trying to get a mean. You're just trying to get a
SAS will happily, so what it's doing under the hood is taking the fixed effects from the model and doing whatever algebra you've told it to do by the line. It will, if you put intercept in by mistake, it will still give you a number. It just won't mean anything.
Yeah, I'm not like 100% sure when you plug in 1 for attitude,
Mm-hmm.
it knows that it's not attitude equals 1, which 1 minus 3 is negative 2.
Right. What you're referring to when you write the variable is the beta that goes with it. It's the multiplier of the beta. So in this case, for instance, attitude 1 is, it's saying that I want one of these. I've already factored attitudes out. And down on beta 3, I've factored attitudes out. So then it's saying, how many beta 3s do I need to get the right level of education?
So if I change that 0 of intercept to 1, then it completely changes the meaning.
Yes, it does. Yep, and that's why I put these in here, like, don't do that. But yes, you have to have the word estimate before each of these. I just ran out of line to do that, but yeah. I didn't do a Stata one, but it's the same idea. The only difference is that you would put stars and then put pluses in the middle. Otherwise, it's the same. All right. Okay. Want to do another one? Yeah. Thank you. It takes practice, but once you see it, you can't unsee it. It's like the magic eye posters. You know those? Where you like stare at it and there's a picture hidden. Ironically, I can't see those, but I'm told there's a picture. But it's one of those things like once you see an illusion, you can't unsee it, even though you never saw it in the first place. Yeah.
So, Can we go back to the last slide?
Yeah.
Yeah. Would that be better if we repress, for example, the attitude, and now become to just beta 1 and education beta 2? Because it seems like it just goes with the coefficient.
Mm-hmm. Yeah, it goes with the coefficient.
But
Mm-hmm.
if you compare this slide with the last slide,
Mm-hmm.
yeah, so this one, it seems like you just literally plug in the attitude equal to 5.
Yes.
Is that correct?
Yes.
Okay.
Yeah, it's the multiplier of the coefficient. It's the question is, how do you want to rearrange the coefficients to give you what you want? And these are examples of giving basically beta zeros. The others are asking for any other beta slope that is a linear combination of other slopes. So if you wanted to, like what beta 1 would be if education is 12 is just beta 1. So that line would just have attitude 1 and nothing else because it would zero out. So that's the one that's given to you by default. But there's a million other ones that are implied by the model that you could ask for if you had a specific reason to care about those levels of education. And so this is where your previous training in terms of interaction terms is relevant. What people would typically do is calculate what plus or minus 1 standard deviation would be in the other variable and plug those values in. And then you get the slope at the moderator at 0, you get the slope at plus 1 and the slope at minus 1. And you make a picture with those. But the plus 1 and minus 1 is an arbitrary choice. You're just trying to show the range of how the slope changes as a function of the interaction term. But that actually sets up this next slide very nicely.
So,
Yeah.
Can I also ask?
Please.
So does it mean like let's say, for example, like if in terms of like a slope, like we took like a 1 to attitude, 0 to education, and if we are also 0 to like interaction, the result of the test would be like similar to the like coefficient test in the like just regular regression.
Similar to what did you say?
The result of like a regular regression, like the individual coefficient test, like in the regression table, like you might see that like a T or Z test result of beta 1.
Yep.
So
Yeah, so each of these, what you'll get in the printout is this label to tell you which one you asked for, a column of estimates, standard error, T, degrees of freedom if applicable, and a p-value. And you can ask for confidence intervals too. Yep. So yeah, it treats it as if it's just another beta. It's a linear combination of betas, and the model has all it needs already to do any linear combination that you want. Yep. Other questions? All right. So certain situations, it's easier to anticipate what simple slopes you might want to report. For instance, if I have gender as a binary variable and I have an interaction with age. If I want to know what the age slope is for men, then I need 1 beta 1, right? And then I got to figure out how many beta 3s I need. So that'd be 1. What goes here? How many beta 2s do I need to get the age slope? 0. Because beta 2 has nothing to do with age. It's beta 3 that I need. Beta 3 times gender specifically, if I want it for men and men are the 0 group, that's a 0. So this is an example of a line that is completely unnecessary. Because men are the 0 group, the slope of age that you get directly out of the model, this beta 1, that is what we just asked for. So anytime you have a line where there's only one term that's not zeroed out, it's in your model already. What's not in the model is the other one. So what goes here if I want the age slope for women? Still 0, because I'm talking about beta 2 at this point, and that has nothing to do with age. What switches to 1 is this. So if this is my analysis, I can think of reporting 3 different numbers. I could talk about what the age slope is for men and whether that's significant. I could talk about what the age slope is for women and whether that's significant. That's not directly provided by the model, but it is predicted by the model. And the interaction term then is the missing piece. Is the age slope for men significantly different than the age slope for women? All 3 pieces of information, the model is only going to give you 2 directly, but a third is an easily obtainable linear combination. So if I'm talking about the age slope as the thing I care about and gender as my moderator, that's it, right? That's end of list if I've only collected gender as a binary variable. But going the other way to interpret this interaction, one way is how the age slope differs by gender, the other is how the gender difference depends on age. Either is equally correct, but if I go the other way, how many beta 1s do I need to get the gender difference? Is gender in beta 1? Nope, that zeroes out. If what I want is the gender difference, then the main effect of gender gets a 1. And now the interaction term carries the modification by the other variable. So if I've centered age at 85 and I want to know what the gender difference would have been at 80, what goes here? -5, yeah. And what would go here if I want the gender difference at 90? 5. So why did I pick 80 and 90? Well, it might have been plus or minus 1 standard deviation, but why not 81? Why not 81.5? Rather than trying to figure out what the simple slope is at each possible level of age, you can do something that is potentially a lot more interesting, which is known as regions of significance. You can figure out at what age the gender difference turns on or off. So it's taking this idea and turning it on its head. So I have an Excel sheet that does this. I wrote a SAS program that does this. So if we know from our t-test whether or not a slope is significant, we can rearrange the formula to figure out what slope we need to get a significant t. So in order to compute this test, you have to ask for an extra piece of output, which is known as cov-b. That is what seems to be the keyword in most different programs. What it gives you is a new covariance matrix that refers specifically to the precision of the fixed effects. The diagonal is each fixed effect's standard error squared, so it's sampling variance. You need the off diagonals to be able to do this. You need the covariance between the betas. That goes into the formula. So here's an example of how one might do this. So let's say that this is my equation, this is my model, and these are my results. So beta 2 in this case, this is the gender difference. I know based on my centering that this is the gender difference specifically at age 85. It's a conditional main effect. And the gender difference right here is such that the women are the alternative group. So I would call this something like the disadvantage for women, right? Women are lower. That's what I'm calling the main effect conceptually. What I want to know is what happens to this gender difference as a function of age. In order to know that, I have to know what the interaction term is. So which combination is this? If I have a negative main effect and I have a negative interaction, what is this interaction doing to my beta 2? More negative, stronger. So the woman disadvantage is bigger in older people. That implies that the woman disadvantage is smaller in younger people. So what age is it where there is no more disadvantage? How young do you have to be? That's what we want to know. So if you work out the formula using the standard errors from the model, and these are the numbers that would show up in the output. I have an example related to this in, I think, chapter 2 is where I pulled this from in my book. It works out that the region of significance for age is 60.16 years to 79.52. So what that means, anywhere above 79, the gender effect is significantly negative, such as what we already know it is at age 85. 79 is the cutoff at which point women get a significant disadvantage. According to the model, between 79 and 60, the gender effect is non-significant. And below 60 is where it actually switches directions. Because if you think about slopes as non-parallel lines, they eventually intersect and go the other way. So the question then is, who is in my sample? In this particular data set, there was nobody. Were nobody? I'm losing English. There were nobodies. I'll do it that way. There were nobodies who were 60. So in describing for whom this age effect holds, you want to focus on the proportion of your sample that falls into these ranges. So for most of the sample, there is a significantly negative gender effect favoring men, women disadvantage. But for anybody who is under 80, it's not a significant disadvantage. So I really like this because to me it makes more sense than just picking an arbitrary point of plus or minus 1 standard deviation and talking about that. Keep in mind these are all just estimates though, and their precision is going to be dictated by sample size and variance and all the other usual things that you have to think about. So I'll show you an example of how to do this in our next work. Yeah.
So the region it gives you is when it's not significant?
It's both. So all interaction terms at some point are positive, negative, or excuse me, all main effects are at some point negative, neutral, and positive. It gives you the crossover points for each of those. Let me see if I can draw. Let me draw real quick. So in this case, if we have, let's put the gender effect on the x-axis. So we have men and we have women, and at age 85, there's a negative slope. 85. We know that it gets more negative as age increases. We know that it gets less negative as age decreases. If you follow this trend, for every year older, the gender effect becomes stronger by 0.11, more negative. For every year younger, the gender effect becomes weaker, less negative by 0.11. You trace this out, 60 is the point where it becomes positive. The question is, do you have anybody up here? Anything of 80 or higher, it's significantly negative. Anything between 80 and 60, it's 0. And anything below 60, it's going to be positive. Yeah.
So did you say that 60 is a point like the difference becomes positive? Or like I thought that it's like it becomes like still negative but like not statistically significant.
60 is where it goes from non-significant to positively significant. It shuts off at 79. So 79 is the point where it goes from not significant to significantly negative. 60 is the point where it goes significantly positive. Yep. So, and we'll get to see an example of this next week. So, have a great weekend, everybody. Let me know if you have questions. Office hours start now, if so.